Okay, this is our project, the solar panel charging project. My name is Imani Taylor.
I'm Anaya Robinson,
I'm Owen Castillo Suarez. I'm Perry Brooks.
and this is our project. So for our problem statement, one of the things that inspired this project was the fact that chemical batteries, they make up a lot of waste in the environment currently, and cutting down the consumption of disposable batteries will greatly reduce the impact McKinley Tech has on the environment.
Okay, our project proposal. In this project, we want to address environmental safety, efficiency, and also educational display. So our design approach was we wanted to create a solar panel cart, a computer cart that had shelves and would store batteries inside. And we would have the computer cart be able to charge batteries using electrical wiring. And our first initial considerations, we were trying to consider the time of the rechargeable batteries, materials that we would need for protection of the solar panel itself, the components of the cart, and also additional functions, and also the physical and visual display. And some milestones that we planned out was that we were going to take apart the whole computer cart to understand how it works. We were also going to create sketches and prototypes for the circuits and then test them to make sure that they work. In all, we want to make sure that Mr. Stemple has a computer cart in his classroom, and also other teachers have a computer cart with a solar panel in it that can help charge batteries, rechargeable batteries.
The work that we completed was we created and redesigned multiple different breadboard circuits, cut out wood outlines and covers for circuits, designed many circuits on digital websites, conducted multiple experiments to discover what circuit designs is most optimal for us. And we optimized the cart in the best ways to fit our needs, like taking it apart, analyzing where innovations and changes need to be made, and putting it back together with the essentials that we need.
Some experience we completed was before building the circuit, we use LEDs to make sure that the flow of electricity throughout the circuit will be able to work on the final project, especially towards like the current side. We discovered that the blue LED used more voltage than the other colors, prohibiting the buck converter from getting sufficient power. So we decided to consistently use the green LED instead. We found out that some of the LEDs have higher values of resistance, so we switched the higher ones with the ones that have lower values to minimize the glow of the LED. And then we originally used button switches, but then we switched them out for the toggle ones instead for optimal usage.
So our first prototype, it worked to an extent, but we were having trouble because we weren't able to supply sufficient power to our battery chargers. Oh yeah, it was a series circuit, which meant that they all had to be on, like they couldn't work independently, which was a big flaw with the project. And it just wasn't super sufficient, so we changed it and we improved it.
Okay, so our second prototype, it was pretty identical to the first one. We basically just moved the switch around, put it in the right place, and we made three more circuits that just liked it. And we made sure that it aligned in like the outline spot. And we also 3D printed holders to put the circuit into and configured for optimal voltage and current.
the steps that we took from 3.1 to 3.2, since the switch was in the wrong spot, it must either be removed or placed elsewhere, or we must start from scratch. We had to make more of the same circuits, so it'd be 4 in total. We had to align the circuits to connect spots to the covers. The prototypes were completed by 4th of April, and everyone should be able to help on the assignment. Well, everyone helped on the assignment.
So right now, our project, we haven't been able to, our individual circuits work, but we haven't been able to supply it with sufficient power via the solar panel. It's not getting enough energy or enough light from inside the classroom, but using a power supply or like a battery with power able to supply our circuit, it works pretty fine. So right now the only issue is that it's not as sufficient or efficient inside the classroom.
Okay, future innovation. So we really want to make sure that the solar panel is charging faster, charging the batteries faster. We also want like a smaller cart for more mobility and maybe even a bigger solar panel, that way it can help charge it faster. And we want to, again, allow Mr. Stemple and other teachers to have this product in their schools worldwide to help access more rechargeable batteries without having to harm the environment in the process. These are pictures of our
These
project.
pictures capture the process of us throughout the year building and working on our project with our first prototypes, discovering, or like initially when we initially started like looking at the solar panel, when we started initially looking at the solar panel and seeing what we have to work with. And thank you to
you.
Mr. Stemple for guiding us through this project and providing us with all the materials and encouraging us to keep going when we felt like we were in a rut. And also shout out to Mr. Grimm, because he was our previous electronics teacher and he gave us a great foundation to get this project off its feet. And thank you to everybody.
Thank you.
Thank you.